Okay, so here's my assembly drawing when it opened up, and you'll notice it says assembly, and it still has the same reference planes top right that the others, that your part does. I'm going to just do a file save as and save it as a template, all right? So I'm going to X out of here, cancel out of there, and I'm just going to say, I'm just going to put it to metric, and I'm just going to say file, save as, and I'm going to put it in my template folder. And if I want it to be a template, what's the most important thing? I got to make sure I save it as an assembly template. Otherwise, I'm not going to see it. And I'm just going to call it assembly millimeter. And that way, I've got an assembly template in my templates folder. Now, if anybody got lost doing that, raise your hand. Ron can help you. Okay? So once I've got that defined, I can just close that up. I don't want to do anything in that template because I want to use that template.
What about doing all the other stuff, like changing it to air?
No, it doesn't matter because this is just an assembly file. All that stuff happens in your drawing, and you've already got your drawing set up. So now notice if I go to my templates folder, now I have an assembly template set up. Okay, so I can open up my assembly template. Let's okay. All right, so when you first open it up, you get this properties panel over here where you can bring documents in. I'm going to cancel out of that just for the heck of it. And I'm just in an assembly file. All right, so if I come over to my folder where I'm saving all my fabulous parts. Notice here are my parts and here are my drawings. I can hold down my control key, and she doesn't show you how to do this in the book, so if you're not paying attention, you're screwed. If you hold down your control key, you can select all the parts that you want to go into your assembly, and then you just hold down your left mouse button and drag and drop them into your assembly file.
Your parts?
You said click the parts and do what?
Hold down your control key, select the part files, hold down your left mouse button, and drag and drop them into the assembly window. You have to be selecting parts, not drawings. No, if you select them all and hit open, then you open part files. And notice here they are. I'm going to okay, mine just dragged in the rod, it didn't get the others. So I have the rod in there. There's the plate, and there's the guide. Okay, so you can just basically drag and drop from the Explorer. Okay? Now, you'll notice here are my parts. If I put my left mouse button over them, I can drag them and move them around. See that? Because these guys are basically floating in space. Now, you'll notice that I have a little F next to my rod, and I've got a minus next to plate and a minus next to guide. Do you see that? What that means is that if it's got a minus next to it, that means that it's under-defined or under-constrained. In other words, it has degrees of freedom available. Okay? If it has an F next to it, that means that it's fixed in place or it's grounded. All right? By default, the first part that you bring into your assembly is going to be fixed in place or grounded. That's because, have any of you ever tried to put together a bicycle or a bookcase and the parts fall over and you need somebody to hold it in place so you can like put the parts together? So SolidWorks by design wants you to have one part not moving around on you, because otherwise if you try to add a part to it and it's not fixed in place, it could go whoosh and go out into, it's like two satellites colliding in gravity type thing. You know, they just kind of both go off into space. So you want to figure out which is going to be your central component that everything's going to kind of build onto, and that should be kind of placed front and center, constrained to the origin. Of the three parts, which one of these do you think should be the front and center main part? The guide, right. So if I have the rod as the one that's fixed in place, is that a good idea? No, because then everything's got to go around the rod, and that would feel kind of clumsy. So SolidWorks makes its best guess if you bring in more than one part at a time, and it doesn't always guess right. Now, let's start again. Let's do another way. I'm going to go new. I'm going to go assembly. I'm going to say OK. Okay, so now what I can do is I can browse. And I'll come over to my homework folder, and I'll select my guide, and I'll say open. Now, if I'm very good and I just hit enter or a green check, it should land my part so that the guide's front plane, top plane, right plane line up with the assembly front plane, top plane, right plane. And notice that my guide is fixed. By default, the very first part that you bring in is going to be fixed. So here I'm going to zoom out a little bit, I'm tilted. Here's the guide's front plane. Here's the assembly's front plane. See how they're lining up? Okay. Here's the assembly's top plane. Here's the guide's top plane. See how they line up? Here's the assembly's right plane. Here's the guide's right plane. See how they're aligned? So in other words, all three planes for the part line up with all three planes for the assembly. Okay, see that? And notice that the parts planes are a different color from the assembly planes. See? But see how everything lines? Alright, now I'm going to show you a third way to create an assembly. I'm going to open up the guide. So here's my guide part, okay? Looking beautiful, I'm sure. And I'm sure all of your parts look equally beautiful, right? I just turned off the temporary axes because we don't need them. Okay, so here's my guide looking fabulous. All right. I can come over here and I can say make assembly from part or assembly. And what that does is it automatically, it asks me what template I want to use. I say okay. Automatically opens it up with the guide there. I hit green check. Done. Okay, so now I've shown you 3 different ways to create your assembly. Way number 1, drag the part in from Windows Explorer. Way number 2, open your assembly template, create the part, and bring in the part. Way number 3, open the part, make new assembly from the main part. I don't care which way you do it. All right, but you all should start with the guide. Now, what if I'm going to say you're a new person and not really maybe very good at assemblies. I'm gonna say here's my guide. And I'm going to insert my guide and I'm going to place it over here. Now notice the guide is fixed, alright, because the first part you come in is fixed. Now I'm going to look at my planes to see if they're lined up. Are my planes lined up? They are totally not lined up, right? They're nowhere near. See that? See how my guide plane is nowhere near the assembly origin? So what do you do if that happens? How do you get your part in the correct place? And this is important because this is something you are going to need for the CSWA, and this is also something you need just for work, because this is kind of like, how many of you are AutoCAD users? This is kind of like drawing away from the 0, 0 point. Okay, if you've ever inserted a block and it's like way over here and 0, 0 is way over here, that's what it's like. Alright, because this part might get inserted into another assembly, and if this part is off the origin, it's going to make it really difficult to put it together. So, so this is like, if you really want to piss people off, don't do what I'm telling you. This is best practices. So how do you fix it? Because remember, this says F, so it's fixed in place. It's grounded. It's fully constrained. It has 0 degrees of freedom. And notice right down here it says fully defined, right? So fully defined means it has 0 degrees of freedom. So what can we do? Oh no! What we can do is we can left click on the part, and right over here it says float. See that? What that does is that removes the ground or the pin and lets it float and basically gives it back its freedom. Okay, so now notice as soon as I selected float, now I see a little minus sign in front of the part. What does that minus sign mean? Not fully constrained. And notice right over here, now it says what? Under defined. And now if I put my mouse over it and drag it, notice I can move it all over the place, and it's got full degrees of freedom. It's got all 6 degrees of freedom. I've got a move component right here. Also underneath the move component, I've got rotate component. So if I wanted to rotate it around, look, I can rotate it all through. See that? Got all 6 degrees of freedom here. It's wonderful. Okay, so how do I fix it so that it's located the correct place? I want front plane to front plane, top plane to top plane, right plane to right plane. Well, I want to use something called mate, right? I want to create a relationship. So if I highlight the front plane and highlight the front plane and select mate, you get this little toolbar that comes up with all the different mates. Notice what we've got: coincident, parallel, perpendicular, gives us all the mates that might be available. We want a coincident mate, and then we green check. And then I want, so I've got the front plane, and notice it's cockeyed, right? Because I rotated it, but it's still got that face mated with the other face. Show you. See how it's moved into position? Okay, so I can still move it around, right? I still have degrees of freedom this way, right? Up and down, this way, right? But I've eliminated some of my degrees of freedom. I want to go top plane to top plane, mate. And I'll green check, and notice how it kind of disappeared. That's because now it's moved up to that plane. And then if I want right plane to right plane, I'll just hit that little plus up here so I can see it. I want this right plane and this right plane. Notice how this is empty. I want right plane to right plane. Boom. There it is. Okay? So now notice minus is gone, and it says fully defined, right? So I'm going to turn off the visibility of the planes because we don't need them anymore. So now what I want you to do is I want you to get your guide in there and get it fully defined. Front plane, top plane, right plane, right plane. And if you need help, raise your hand. Ron will come over and help you. Yes, Stephen.
So if you run all the parts in at the same time, you can still just align the guide on its own.
Yes, you can still,
It doesn't matter, right?
right, it doesn't matter. You can still, what I would do is I would float the rod because it's, nowhere. But I've got, see, I can still do the front plane right here, even though I've got all the parts in there, and do the mate.
So what we're doing there is aligning the guide to the planes in the assembly.
Correct. Because you're trying to get, because you want to, we're in three-dimensional space, you have to have control over your space. And if you get lost, have Ron come over and help you. Yes, Anna?
Can you just align the two origins?
You can, but what that does is that you still have rotation.
So, if you align just one plane in the origin, or do you have to align all three planes and the origin?
If you do the three planes, you don't need to do the origin. Right click, highlight the item, right click and go float. Okay, so next I'm gonna bring in the rod. Now if I want to bring in the rod, see right here where it says insert components on the ribbon. I can click on insert components and then browse. And then locate my rod and bring in my rod. And I'm just going to place the rod there. So my rod's in here, and you'll notice my rod has a little minus sign next to it because it's under constrained. It's got full 6 degrees of freedom. What I want to do is I want to add a concentric constraint between the rod and this hole right here in the front. So I can do a couple of things. This can work reverse Polish, or so I can select the parts or features that I want to mate, and then the mate tool, or I can select the mate tool and then what I want to mate. It can work either way. So I'm going to hold down my control key. I'm going to select this face so it highlights, and then I'm going to select the hole so it highlights. And notice that I was very careful to select the cylindrical face of the hole. And then I select mate. And notice it previews what it's going to look like, and it says, oh, you must want a concentric mate based on what you picked. Now that's very cool, right? And it was very fast. Now what if, I'm going to cancel out, what if I had selected the mate tool first? If I select the mate tool first, it's giving me this blank box asking me what I want to mate. I'm going to say, oh, I want to mate this cylindrical face and this cylindrical face, and then it previews and it says, oh, based on your selection, you must want a concentric mate. So which one was faster, way number 1 or way number 2? Yeah, about the same. Okay, so then I'm going to green check. I'm going to cancel out. Now you'll notice that the rod still has a minus on it. Also notice under my mates folder, I can see a list of all my mates and what's mating to what. So it says this is the guide and it's mating the front plane, this is the guide that's mating the top plane, this is the guide mating to the right plane, this is the guide mating to the rod. Now this number 1 is basically a count saying there's one guide number 1 in the assembly. If I had more than one guide, I would have guide number 1, guide number 2. It's kind of SolidWorks way of keeping track of what's what. And notice it's highlighting. When I highlight that concentric mate, it shows me the 2 faces that are constrained. Now, it's saying under defined here, notice if I put my left mouse button, I got a degree of freedom here, right? I also have rotation. Do you see that? Okay, so how many degrees of freedom do I have left? 2. Okay, so I want to use my keyhole. I want to say this flat face is parallel to this face. All right, so how do I do that? And if I do that, if I say that that face is parallel to the other face, which degree of freedom am I eliminating? The degree of rotation? Yeah, I'm eliminating the degree of rotation, not the degree of translation. Translation meaning to move, rotation meaning to rotate. Okay, so if I go mate, and then I select this flat face and then this flat face, notice it says, do you want them to be coincident? If I say select coincident, I'm going to get an error because they're nowhere near each other. If I say parallel, that's okay. If I say perpendicular, that would make them 90 degrees. That would be okay too. I want them to be parallel, so I'm going to click on parallel, and notice it just rotates into position. And then I'm going to green check. Okay. Notice I still have translation. Okay. I think I have some interference. I think my guide hole is too small. Question?
Yes, concentric could be done with the temporary axis. Temporary axis. You'll get the same result.
If you select the temporary axis, if I use the temporary axis, I normally would do a coincident constraint.
Yeah.
And you might recall last class I changed the hole for the drawing to 8 millimeters, so I'm changing it back to 10 so I don't have interference with the rod.
Oh, okay. How did you see you had interference?
I could just see that I had interference. Okay, so now it looks right. Okay. All right, so we have one more part we want to bring in. We want to bring in the plate. So I'm going to go insert component, browse. I'm going to bring in the plate. I'm going to say open. There's the plate. All right, now when I bring it in, I want this concentric hole to be facing away from the guide, so I can come over here to the rotate component and I can rotate it so that it's in a better position. Okay? And then right click select. So I want to do a concentric mate between the center hole, and I can either use the hole or the outside face. It doesn't really matter because they're all concentric. And I also want to do a coincident constraint between this flat face and the end face of the rod. So those are the two mates I want. So I'm going to say I want a concentric mate between this hole and this hole. And then I'll green check. And then I also want a coincident mate between this face and this face. I notice that places it right there. See that? And then I want to do parallel between this face and this face to rotate it. And notice I have this face on the bottom. If I wanted this face on the top, it doesn't really matter because it's a symmetrical part. I could change the direction right here where it says flip mate alignment, and that would turn it over to the top. And then I'm going to green check. And I'm going to save. And I'm going to call this guide assembly. Guide assembly. Bless you. Bless you, bless you. Yes. If I want to flip a mate, so see right here on this tool right here, I could also here, this determines whether they're opposing or aligned. Okay? Good. Everybody got this? Everybody with me so far? No. Saved it so I didn't lose my work. Okay. I am now on page 2-32. And what I want to do is I want to bring in some hardware. Okay? Everybody with me? Okay. So on my resource bar, I've got this little library. Do you see it? I'm gonna expand it out. All right, now I have a toolbox, and notice I have toolbox up here. Some of you may not have toolbox. How many of you do not have toolbox? Okay, so I'm going to show you how to get toolbox in a minute. Okay, right now we're just going to go to the design library. So the design library is right here. Everybody have your design library? Everybody see the design library in your resource panel? It's the very top. So you should be selecting on the resource panel, you should be selecting the third tab down with the little library books, and you should locate the design library, and then I want you to click the little plus right here. And you notice we have annotations, assembly features, parts, routing, right? We want to select the parts folder, and I'm going to pin this. So if I pin it in place, it's not going to collapse on me as I'm working. Okay, I'll unpin it when I'm done with it. So I want the parts folder. Can everybody locate that parts folder? Okay, so you want to select that parts folder, and if I click down on the parts folder, notice I've got a bunch of different folders, and I want the hardware folder. Do you see the hardware folder? Okay, so I'm going to select the hardware folder. I'm going to open that. And notice when I select that, I've got a cotter pin, a flange bolt, a gear, a nut, and a retaining ring in that folder. Everybody see that? Okay. So what we want is we want the flange bolt. We want to bring in 2 flange bolts. Now normally in real life I would be using the master car because then I know I'd be getting a real part. But for the purposes of just this assembly, we're going to use the flange bolt. So I'm going to hold down my left mouse button and I'm just going to drag this part into my assembly. You can only add fasteners to an assembly. You cannot add fasteners to a part. I know that might sound interesting, but some people actually will try to bring fasteners into a part file and it won't work. Alright, you can only bring part. Now you want to select the M8-1.2530 configuration. That's at the very bottom. And you want to say OK. And notice I can place more than one. So I'm going to place 2. And then I'm going to hit the X, red X. And then I'm going to uncheck the auto show. And I'm going to bring it back. So I have 2 flange bolts in my assembly. I'm going to save them. And notice the flange bolts are listed here. And one is said flange bolt 1 and one is said flange bolt 2. That's the count part that I was talking about earlier. See that? Now someone asked about using the temporary axis. Who asked that? You did. Good job. Okay, so here we have a slot, right? And what if I wanted to center the bolts in the slot? Because I could make them use the concentric face to put them on either end of the slot. But what would I use if I wanted it centered? And one of the things I could use is a temporary axis. Okay, so if I turn on my temporary axis, notice I've got that blue line in the middle that I can use to constrain my flange bolt. Do you see that? Was everybody able to turn on their temporary axis? Do you remember how to do it? You go to View, Temporary Axis. Got it? Everybody there?
My bolts are putting down.
That's okay because you can rotate it. Okay? So, I want you to watch me a minute because this isn't in the book. Alright? So I go mate I can't use a concentric mate because an axis doesn't have a circular face to it. All right? So I want to use a coincident mate. I'm going to select the center axis, and notice it highlights and it says axis. And then I select this face, and it goes upside down. Somebody else said, oh, it went upside down, now what? Okay? Well, if it goes upside down, it's okay, because we can flip the mate alignment in a minute. Okay? For some reason, it's not showing it here. Right? Might be because I did a face instead of an axis. Okay, so if I select this axis, then it goes the correct way. All right? See that? Now if I wanted to flip it, I could flip it here. Okay? And then I'm going to green check. And then I'm going to add a coincident constraint between the face and the bottom of the flange on the bolt. Green check. Okay, so I'm going to do it again. I'm going to do a coincident constraint. I'm going to select this axis. Notice I'll zoom in and out so that I can see what I'm selecting. Totally okay to do that. And if it comes in upside down, I just flip it. And then green check, and then add the coincident constraint. Now it's still going to have a degree of freedom. It's still showing underdefined. Why is it underdefined? It can still rotate. Okay, the rod has degree of freedom because it can go in and out. The plate has degree of freedom because it's traveling with the rod, right? And these guys have rotation, right? Okay? Now, I'm going to turn off the visibility of my temporary axes because I don't need it. I'm going to save. Everybody good? Ron, we got, Alon needs some help.
It says confirm that it must be saved. These components must be saved at the same time as it's typing.
So just,
Everything else open.
so it's probably the flange bolts need to be saved? Okay. So, yes. I wanted them coincident so that it's resting on the guide. Okay, now we have a problem. I don't know if you can see this. I'm going to rotate it over. But if I zoom in here, look at the size of the bolt versus the size of the slot. Do you see that problem? It's called interference. All right? So, some people, they're not paying close attention. They might not realize there's an interference issue. So I want to, this is not in the book. Okay? I'm going off script again. I want you to show you how you can check for interference, because that's important. It would be very bad for you to put in a component that is going to have an interference issue, because then when they start building the assembly out on the line and parts don't go together, who's going to get blamed? You. Ron. Yeah, not. No. So we need to check for interference before we get too far down the design path. So how do we do that? We go to the Evaluate tab right here. Okay, so I'm going to the Evaluate tab, and right here on the Evaluate ribbon, you have a tool called Interference Detection. Do you see that? So if I click on Interference Detection, I say I just want to look at everything in my assembly and calculate. And then notice it shows me all the areas where there's interference. And notice I can highlight it and it'll show me where it's interfering. Do you see that? Okay, so you can see where I've got a problem. All right? So how do we fix it? Well, this guide bolt is an M8. Does anybody remember what the radius of the slot is? Yeah, it's a 6 diameter. So we need to make this slot into an M8, right? So we can come over here to the slot and say edit feature, or we can double click on the guide and notice it'll bring up features, but it's just going to bring up, if I double click on the slot, notice it'll bring up that 6 dimension. Do you see that? Yeah. And then I can click on that 6 and I can change it to 8 and green check. And then to make sure it takes it, I'm going to come over here and I'm going to rebuild. So I'm going to go Control B. And now when I look at it from underneath, it looks good, right? Looks better. So now, if I do an interference check and calculate it, notice it only sees a little bit of interference right here, and that I can ignore, right? See that? Sorry? That's just part of the top of the flange, so I don't really worry about that. I can ignore that. Okay, so I'm saving it. Okay. Everybody good so far? No? Not even close.
How do we click on it? How do we get to edit that recording?
I locate the slot in the browser.
Yeah.
Double left click on the slot.
Yeah.
That should bring up the dimensions. Select the 6 dimension, change it to 8. And then do a rebuild. The rebuild looks like a little traffic light on the standard toolbar. Yes.
We get out of here.
You don't have, yeah, you close off that dialog. Oh, so then you have to change it to 4. Yeah. Yeah, exactly. It just eliminates a part, right? It eliminates a couple of parts, so that reduces your assembly time, right? It reduces your part count, which everybody likes, because you don't have to deal with that, ordering those parts and keeping inventory on those parts, right? I'm not saying that you have to do it that way. This is just one way, right? Okay, so we also need a countersunk cap screw right here. Okay, that's going to come in the toolbox. Now, not everybody has a toolbox, so I want to talk to you about how to get the toolbox. And for those people who are on computers, you need to have this as part of your flight checklist, so that if you don't have the toolbox, you know how to bring it up. Okay? It's also one of the reasons that a lot of companies don't like the toolbox and don't use the toolbox is because the problem with the toolbox is it saves where it saves those components. Okay? By default, it saves those components in a folder under SolidWorks, not in your projects. And that creates problems when you want to send your assembly out to somebody. Also, if you want to give your assembly to somebody and they open it up and it's missing a bunch of hardware, that can create an issue. So how you set up your toolbox is going to make a big difference. Okay, so I'm going to come back to the assembly. Some people still need help from Ron, I think. Okay, so To set up your toolbox, if you do not have the toolbox available, you want to go to Tools, and you want to write this down even if you do have the toolbox available, because you may come up sometime and find SolidWorks with the toolbox closed. You want to go down to Tools and you want to scroll all the way down to the bottom until you see the word Add-ins. So we're going to do Add-ins. So you go Tools, Add-ins. And notice that I have a checkbox next to SolidWorks Toolbox and SolidWorks Toolbox Browser. Okay, if you do not have a checkbox, you're not going to see Toolbox. Everybody see it? Everybody got it? Good. Okay, and then I'm going to say okay. That will add the toolbox to your menu and to your design library. But you are not done yet. You still need to tell Toolbox where and how to save the hardware. If you don't do that part, it's going to create problems. You'll open up your assembly and you won't have your hardware. Okay? So if you go to Toolbox, you want to select Configure. See right here on the menu, under Toolbox, you want to select Configure. And again, you want to write this down so that if you have any problems later, you'll be able to get it set up correctly. Question?
For the startup, is the right column?
Sorry, what?
For the, when we were doing the boxes for checking it, since there's 2 columns.
Right, you want me to talk about that?
Yeah.
Okay, so there are 2 columns. 90% of the time I don't use Toolbox. Toolbox is accessing a database and it's taking up memory or resources. All right, it's going to slow down my system. So my choices are to have it active just now or to have it active every time I bring up SolidWorks so that it's always available. So if I have it checked on this side, that means that whenever I start up SolidWorks, it's going to come up, which means it's going to take up memory and resources. Okay? If I have it checked here, it means that it's enabled.
So as long as it's checked on the
Left side, it's available to you.
Okay.
But it's always in the right library menu, right?
If it's checked here, that means that it's going to be available every time you start up SolidWorks.
Right.
Okay.
If not, it's going to be always in the library menu on the right side.
If you check here, then it'll always be on your library menu and it'll always be up here in this menu. Okay? So if I uncheck it, next time I start up SolidWorks, I'm not going to see it. But on the other hand, it won't take me so long to boot up SolidWorks. Okay? All right, but see, even though I unchecked it on the right side, see, I still have it available because I have it active just for this work period. Okay? Now I want to go to Configure. This is really important. Okay, now Configure, you see a bunch of pages. All right? One just talks about your whole wizard. 2 allows you to eliminate just the hardware that you use within your company. We're not going to do that. 3 is the number 1 thing, so you can skip directly to 3. Okay, and this is where it's really important. You want to have it set to create parts, and what that does is it's going to create a part file for you every time you create files. And you want to click on this ... and make sure that it's saving the parts to your flash drive, to your projects folder. So this is what you should see. You should see create parts, and you should have it set to your projects folder, and then you're going to hit save.
I missed where you got this screen right here, the toolbox. That's under.
Toolbox configure.
Oh, here it is.
Is there anybody who's having problems getting their toolbox configured and needs help? Everybody good? Okay, so now we're going back to the resource panel, to the library. Going to expand it out. Going to pin it in place. And now you should see toolbox right here in your library. We're going to expand it out. We want anti-metric. We want bolts and screws. We want socket head screws. So I want to see anti-metric, bolts and screws, socket head screws, and if you look down here, you'll see a bunch of screws. See that? It's kind of like having Home Depot in your computer.
What's that?
Less time looking. Okay? We want the socket countersunk head cap screw. Because we've got a flat head right here. Everybody with me? Good? Alright, so then the next thing is, notice it doesn't give me sizes. What's going to happen is if you do this right, it will auto-size for you. If you do it wrong, you can still change your mind as you go. Okay? So, I kind of show my hole. This is where I want it to go. I put my left mouse over the hardware I want. I drag it over to the hole. I release my left mouse button. Now there's a pause while it accesses the database to see all the hole sizes and socket head, flat head screws it's got. Okay, so you'll notice it came up, and it shows me that it's going to be an M4 screw and a length of 8, because it knew by the size of the hole that I picked, that was the hole of the fastener that goes in. Now, if you weren't as lucky in your selection, which can happen, you got a little drop down right here where you can change the sizes. So if it's oh no, I really wanted something else, you could pick something else. But we do want an M4. I'm going to green check.
Question.
Yes.
What if the screw goes in, but it's in backwards?
I'll show you. Okay. So, well, mine came in sideways. See that? Okay, so here's mine sideways. Notice mine doesn't have a mate to it. Alright, so I'm just going to drag it away. Shoop. Come on. Come on. There it is. Okay. Alright, and then I'm just going to use my mates. Now, I could select the mate and so I'm just going to do a concentric mate there. It's needs to flip, so I'm going to just turn it around and then green check, and then I'm going to do a coincident mate between the top face of the screw and the plate, and I'm good. Now if I have a mate there and I need to flip it, I can highlight it, right click, and say flip mate alignment, and then it'll automatically turn it around.
Oh, in the mate. There we go.
Okay? Got it?
Yeah.
Yep. Easy. Anybody needing help, raise your hand. Question?
So the hole is too small for my screw, and I have to get 4 screws, so that means I need to hold the wrong size. Can I go and edit part 2?
Just like you did for the guide.
Okay.
Now we also have these M3 tapped holes on the inclined face. Remember those? I want to add some socket head cap screws to those holes, but I'd like you to watch me. Okay, because we have an array, we can capitalize on that array. Remember, we have a linear pattern there for those holes? So I want you to watch me. So I'm going to come over, I'm going to locate the socket head cap screw right here. Alright? I'm going to hold down my left mouse button, drag it over. Notice it auto-placed. See that? Okay, automatically knew that it was an M3, length of 5. I'm going to green check it. And I'm going to X, cancel out. Now if I look at this screw, it automatically applied the concentric constraint and the coincident constraint. See that? So it was really nice. Right? It's not always that lucky. I wasn't that lucky with the flathead. Sometimes it works, sometimes it doesn't. Kind of depends on how good you are at your selection. Now what I want to do is I want to linear pattern this screw onto the whole tapped holes. So I need you to watch me. So what I'm going to do is I want to say I want to do a feature driven component pattern, which is on the drop down right here. Feature driven means it's going to be driven by a feature in the part. And the feature that's driving it is that linear pattern that we use to create these holes. And notice which hole I selected. I selected the parent hole of the linear pattern to make it easy. Yes?
You have to remember that that's the parent hole
No, you can tweak it so that if you pick the wrong hole, then there are workarounds. No, it doesn't actually, because what you can do is, I can show you how you could, there are little cute ways to work around it. Basically, you say, this one's the parent, you designate which one's the parent, okay? So I'm going to say I want to do a feature-driven component. It says feature-driven, components to pattern. Well, I want to pattern this, all right? And then it says, what's the driving feature? Well, the driving feature is going to be that linear pattern. So I come over and I locate that linear pattern right here. See, that says small holes. And notice it previews. And you see right here where it says select seed position? So that tells me, see, it's showing me where the pattern is, so I know this is the seed feature right here. So that's my workaround. If I didn't place it in the right place, I could just tell it which one's the right place, right? Okay? And then I green check. What's cool about this is then if my linear pattern changes, the number of screws are going to change, or the spacing of the screws will change. I don't have to go back and edit it. See that? So how cool is that? Right? So there's my fabulous assembly. All right? This is all I expect you to do. In the book she had you bring in another part, and I don't want you to do that. That's kind of annoying. So here's what I expect you to do for your assembly. Just this, up to here. Okay?
Your socket bolt, was that, did you make that with the plate, or was that just concentric?
This one?
Yeah.
Yeah, it's got a coincident constraint between this face and this face. Okay? All right? Any other questions? We are in lab. You got an hour and a half to do your homework.